Chemistry, we're on to a new unit. It's called Advanced Atomic Theories. We're going to start with a lesson on basic waves. So, a wave is the movement of pure energy through space. A medium is a substance with mass that carries a wave. A wave can require a medium to carry it. For example, an ocean wave uses water to carry the energy of the wave. Sound waves are carried by air or water or even through the ground. Some waves can travel without a medium. The most important of these are electromagnetic waves, which can travel from the sun to the earth through outer space where there's no air or other medium to carry them. We will focus on electromagnetic waves in this unit. There are two basic types of waves, transverse waves and longitudinal waves. So transverse waves move up and down as they travel from left to right. So if you were to identify a single point on that wave, and that could be a spring, for example, any point on that spring is simply going to move in an up and down fashion. But the energy is traveling from left to right. So it's passing energy from left to right, but the spring, any point in the spring is fixed, so it's simply going to travel up and down. Longitudinal waves move back and forth as they travel from left to right, and they require a medium. So there you see where it's like a slinky. It squeezes and releases, squeezes and releases. Generally, waves need some type of matter to carry them. This matter is called a medium. The medium could be in the form of a rope, so you can shake a rope up and down like that. A spring, same thing. You can either make a transverse or longitudinal wave with a spring. You can only make a transverse wave with a rope, but you can make either kind of wave with a spring. And air particles. So the air particles, as you hear a sound, the air particles are being squeezed and released as they hit your eardrum, and that sends a signal to your brain that gives you the sensation of sound. In this unit, we will only deal with transverse waves, like the one you see below. Here are the parts of a transverse wave. The crest is the top of the wave. The wavelength is the distance between two crests. A cycle is the movement of a wave from one point to the same point on the next wave. And amplitude is the height of the wave from the central axis. So you can see that over on the right. It's not from the top of the wave to the bottom of the wave. It's from the central axis to the top or from the central axis to the bottom. Now, wavelength and cycle look somewhat the same. They start at a crest and they end at the next crest. The difference is a wavelength is a straight line distance, and it's measured in the units of distance, such as meters. Whereas a cycle is simply a number of times that the wave goes down and comes back up, down and up, down and up. Doing that is a cycle. So you're watching a transverse wave, that's you, the little boy and girl, that is moving to your right. So you're standing above a crest labeled A. When your watch reads 0 seconds. So while you're standing there, you haven't started your stopwatch and the wave is not moving right now. Now 1 second later, the wave has moved and you are standing above crest B. During this time, 4 cycles have passed you, so count. From crest A, you go down and up 1 time, down and up a 2nd time, down and up a 3rd time, down and up a 4th time. So that's 4 cycles. The frequency is the number of cycles that pass a point each second. So it's cycles per second, so since 4 cycles passed you in 1 second, then that would be a frequency of 4 cycles per second. The way it's often expressed is in hertz, Hz, that simply means cycle per second, or there's some that are used in chemistry quite a bit, 1 over seconds. It's the reciprocal of seconds, 1 over seconds, which can be expressed as seconds to the -1. So any of those 3 units of measure are all the same. Note the 3 different ways the units for frequency can be expressed. Period is the amount of time that it took 1 cycle to pass a point. The period is the reciprocal of the frequency. So period, which is expressed by the capital letter T, or symbolized by that, is 1 over the frequency. And similarly, frequency is 1 over the period. So in this case, the period is 1 over 4 that would be 1/4 of a second. So if the frequency is 4 Hertz in the last example, so this relationship can be seen below. It takes 4 cycles 1 second to pass a point, then each cycle takes 1/4 of a second. So you see there's a 1/4 of a second there, a 1/4 of a second there, a 1/4 of a second there, a 1/4 of a second there. So that's 4 cycles in 1 second. So the period is 1/4 seconds. In this unit, we will only deal with a special type of transverse wave called electromagnetic waves. Common examples of electromagnetic waves are all energy from the sun, including light and heat. Energy going into and out of an atom is in the form of electromagnetic waves. Waves that a cell phone sends and receives. X-rays used by doctors and dentists. In this unit, we will be studying the energy that enters and leaves an atom. This energy is in the form of electromagnetic waves. In this unit, we will be dealing with electromagnetic waves. All electromagnetic waves travel at the speed of light, which is that number you see there. We usually just say 3 × 10⁸ meters per second, 300 million meters per second. The speed of light is represented by the letter c, small c. So sometimes a letter represents different things in completely different contexts. So we've seen that letter c used for specific heat in our thermochemistry unit, but here it just has a completely different meaning. So sometimes you have to know what the context is, what the subject is you're dealing with, to know what the c would represent. In this case, it stands for the speed of light. And it's not a variable. It's always 3 × 10⁸ meters per second. Electromagnetic waves have an electrical part and a magnetic part. These travel together as shown in the diagram on the right. So the electrical part is going up and down, and 90 degrees perpendicular to that is the magnetic field going side to side. So you can see how they travel together. Electromagnetic waves do not require a medium. This is why the Earth receives energy from the sun through the vacuum of space. And a vacuum is a place where nothing exists, not even air. All right, and that takes care of our introductory lesson on basic waves. You may have had this in physics at some time in the past, and we'll be dealing with these terms in this upcoming unit.